Hello everyone, welcome back to my channel. I hope everyone is doing great. Let's solve today's Leetcode problem 1930 unique length 3 palindromic subsequences. Given a string S, return the number of unique palindromes of length 3 that are subsequent of S. Okay. Note that even if there are multiple ways to obtain the subsequent same sequence, it is still counted as one. Okay, a palindrome is a string that reads the same forward and backward. Okay, he's just telling the definition of palindrome and they're telling the definition of subsequence. Okay, so let's look at the example. Okay, we have been given a string S where A, B, C, A. So what all possible subsequence we can generate and which are actually unique. Okay, it turns out to be we can only generate three subsequences which are length 3 and which are unique. Okay, so one is basically ABA and AAA and ACA. Okay, this is what these are the three unique subsequences which you can generate. Okay, so I've just restated the problem statement over here. Given a string S, we have to find out the number of unique palindromes of length 3 that are subsequent of S. Okay, so if you notice that this A, okay, so let's see, since we have to generate subsequences which are length 3. Okay, so let's assume that the first character is star. We don't know what is the first character. Since it's a palindrome, whatever is the first character or the zeroth character, it has to be same as its second. Let's, if we assume that we are going with zero base index. Okay, so the zeroth index character should be same as the second index character, right? So whatever character comes over here, it has to be over here, and this character can be anything. Okay, so if you look at our constraints, S contains only lowercase English letters. Okay, that means we only have 26 lowercase characters, right? Alphabetical characters. Now, so the first character, the zeroth character, can take 26 unique characters, and the first character can also take 26. So the total number of possible subsequence which can be possible is 26 times 26. Okay, if I know, if you look at this example, if I know the first occurrence of a character and if I know the last occurrence of a character, all the unique characters which are coming in between are resulting in my solution, are contributing to my solution. Okay, if I freeze my first character, that means the last character should also be the same. So what should be the last? I should also know the last occurrence, because since they have mentioned only unique palindromes are valid, so this ABA is actually invalid for us. Okay, if you see ABA, this is actually invalid. Okay, because we only want unique. Okay, so since we only want unique, since these two are contributing to the same palindrome, all we have to know is to understand what is the last occurrence, leftmost occurrence of a particular character, and what is the last rightmost occurrence of a particular character. If we know these two, then all the unique characters which are falling in between will be counting to my solution, will be contributing to my solution. Okay, so here we have three unique characters. So the subsequences which are starting with A and ending with A and which are length 3 are 3 here. We can form three such subsequences. One is AAA and one is ABA and another is ACA. So these are the three subsequences which are coming from starting character A and ending character A. Okay, now that you understood what is the thought process behind this, so idea is to generate what is the first occurrence and what is the last occurrence. Okay, so this is the optimal solution. Okay, so what I've explained is the optimal solution. The brute force solution is basically to generate all the subsequences of length 3 and check whether each subsequence is actually a palindrome or not. Okay, so I've also implemented that solution as well. I will I will be including it in the comment in the description section. You can actually go through the brute force solution as well. Okay, so let me first explain you the optimal solution. Okay, so as I mentioned, we require the first occurrences of each and every character. Okay, so we only have 26 characters, so I defined an array of 26 length, and we also need to understand the last occurrences of a character. Okay, so that will also be size of 26. Okay, I just filled the first occurrences with -1, indicating that if it is not -1, that means I can say the character exists. Okay, if it is -1, implies that character doesn't exist in S. Okay, so I just fill everything with -1, and I'm just iterating through the string, and whenever I found an index, okay, I'm just at each index I'm trying to calculate the index in this array. Okay, so the character minus the a will give us the index in which we have to populate it. Okay, so if it is -1, okay, that means we have encountered this character for the first time. Okay, then we have to replace it with the current index, or else we should not do anything. Okay, we should leave it as it is. Okay, whereas the last occurrence, that means last occurrence is basically the every time we encounter we have to update the index. Okay, that is the reason we are updating last occurrence of a particular index every time. Okay, now that we have these two in place, okay, so as I mentioned, for each character I should identify all unique characters which can fall in between these two. Okay, so the first character so the first position can take 26 possibilities. So I was just checking for each and every possibility that I will start from 0 till 26. That means I will check for each character possible for the first position and the last position. I will freeze these two positions, and I will check what all unique characters I have in between these. Okay, so if the character itself does not exist in the given array, then I don't have to do anything. Okay, if there is no first occurrence, that means obviously its last occurrence will not exist. As a result, I will simply continue. If the first occurrence exists, that means its last occurrence also will at least exist once. Okay, now that I need to identify what all characters that exist in between those two. Okay, I know the first occurrence, I know the last occurrence. I should now identify the characters in between. Okay, that means I should start from index which is next to the first occurrence and go all the way up to the last occurrence of that particular character. Okay, and I should take unique characters. Okay, if there is one more a here, that means that is not contributing to our solution. Okay, so I've just defined a character set which will basically only include the unique characters. Okay, now and then I'm just populating the character between. Okay, now how many, whatever the size we will be of this character between, those many unique palindromes can be formed. Okay, so that will be contributing to my answer, and then I will just return it. Okay, let's just submit the solution. Let's see, as you can see, all the test cases were passed and it is pretty efficient solution. Okay, so before jumping dive into the time complexity analysis, I highly recommend you to subscribe to my channel so that you won't be missing the content I am posting on daily basis. Okay, so let's analyze the time complexity and the space complexity. So we have defined two extra arrays which are of size 26. Okay, so this is constant size. Okay, so we can consider it as a constant space over here, and we are just iterating to the entire array once. So this will take a time complexity of O of n, and this will also take a time complexity of O of 26, which is also constant. So this entire thing is constant time and space so far, and this is order of n time complexity. And here for each character I'm just checking the characters in between. Okay, so this will also take 26 times O of n in worst case, so this is also O of n in the worst case. Okay, so the overall time complexity of this algorithm is O(n), and space complexity is constant because we are only taking 26 character space. Yeah, that's all about this problem. Do subscribe to my coding channel for more such videos. If you like the content I'm posting, please hit the like button and share your valuable feedback in the comment section. Thank you.